Hey everybody, Mike here with the substitution method. Let's go ahead, let's take a look at that. And 8.2. We're going to solve systems by substituting. As before, our solution to this system is going to be an ordered pair. We got to get a number for x, we got to get a number for y. Now, the system that we're starting off with right here has the form of y is equal to. Both of these equations are solved for y. So what we do is we just go and we set them equal to each other. 3x minus 4 is equal to x plus 2. We know how to solve that for x. We subtract x from both sides, then we add 4 to both sides, and after we divide by 2, we get x is equal to 3. So we found x, but we still need to find y. To do that, we substitute x back into one of these equations. I chose this bottom one here so that we get y is equal to x plus 2. Y is equal to 3 plus 2, or 5, so our solution is 3, 5. And we'd get the same number if we chose to plot them on a graph. Now, in this system right here, y minus 4 is equal to x plus 5, y is equal to 6x minus 1, we have one equation solved for y. So what we do is we substitute it into the other one right here for that value of y, and then we can solve. So we've got 6x minus 1 minus 4 is equal to x plus 5. So 6x minus 5 is equal to x plus 5. By subtracting x, we get 5x minus 5 is equal to 5. We add 5 to get 5x equals 10. Division gets us x equals 2. Once again, we substitute back into one of the equations to get y is equal to 6 times 2 minus 1, which is 11. Our solution is 2, 11. We should probably be checking these and doing something like y minus 4, so that's 11 minus 4 is equal to x plus 5, 2 plus 5, 7 is equal to 7. That checks out. And I know we just substituted it, but it's good practice to check in both of them. 11 is equal to 6 times 2 minus 1 is equal to 12 minus 1. That checks out as well. So this is a good solution. Next, let's solve this. This top equation has x is equal to, so we're going to substitute that 1 minus 3y into the second equation. We want to be careful here because when we substitute, we're going to do that in parentheses. We get y minus the quantity 1 minus 3y is equal to 11, and this becomes y minus 1 plus 3y after we distribute. So y minus 1 plus 3y is equal to 11. 4y minus 1 is 11. 4y is equal to 12. Y is equal to 3. And we know that x is equal to 1 minus 3y, which means that x is equal to 1 minus 3 times 3. X is equal to 1 minus 9, which is a negative 8. So let's check. Negative 8 is equal to 1 minus 9. Yup, this checks out. I mean, we just did it, but still, if we made a silly error and said plus 8 instead of negative 8, we'd be able to catch that. And now let's check this one. So that's 3 minus a negative 8 is equal to 3 plus 8 is equal to 11. So the second equation checks out too. Our solution is xy equals negative 8. Great. Next problem. Sometimes we need to solve. In this system right here, neither the top equation nor the bottom equation, x minus y equals 1, x minus 2y equals 11, is solved for either variable. But what I'm looking at is the top equation here, because that's the simplest. it's got that form x minus y. And if I just add y to both sides, I get x is equal to y plus 1, which is pretty easy to substitute, especially since over here this is just x all by its lonesome. It's not being multiplied by -2 or anything. Let's just get rid of all that nonsense for a second. So once we do that, we get y plus 1 minus 2y equals 11. Negative y plus 1 is 11. Or y is equal to a -10, which means that x would be a -9. And now we really want to check both of these systems and make sure that our solution is correct, because we did a lot to this. So let's see here, -9 plus 10 is 1. Yep, that checks out. -9 plus 20 is 11. Yep, that checks out. Cool. Let's solve this system. I'm looking right here at this equation, and I'm thinking w is equal to t minus 10. Then we can substitute that into here and get 2 times t minus 10 plus 3t is equal to 5. So 2t minus 20 plus 3t is equal to 5. 5t is equal to 25. T is equal to 5. And if t is equal to 5, then w is equal to 5 minus 10, which is a -5. So we'd say wt is equal to -5, 5. Well, let's check this. -10 plus 15 is 5. Yep, that checks out. -5 plus 2 is equal to 5 minus 8. -3 is -3. Yep, that checks out. Cool, we got it. Let's do a word problem here. The perimeter of a fence around the children's section of the community park is 268 feet. The length is 34 feet longer than the width. Find the dimensions of the park. Okay, let's start with perimeter. Perimeter is twice the length plus twice the width, and we know that the perimeter is 268 feet. And then the length is 34 feet longer than the width. Length is the width plus 34. And you know what we have right here? We've got a system of 2 equations and 2 unknowns, and it's ready for substitution. 2 times w plus 34 plus 2w is equal to 268. So 2w plus 68 plus 2w is equal to 268. 4w plus 68 is 268. 4w is 200. W is 50, which means that the length is 84. And checking that, let's see here. 2 times 84 plus 2 times 50. 2 times 84 is 168 plus 100 is 268. That checks out. And the length is 50 plus 34. Checks out too. So it is 50 feet by 84 feet. Cool. That's it for this section in this video. I will see you next time.